Welcome to Precalculus Concept 24F. Underneath trig functions and the unit circle, we're going to talk about using periodic properties. 3 boxes. So let's talk about box number 1. Let's first talk about what it means for us to say the word period in terms of sine, cosine, and tangent. Okay? So what is the period of these functions? Well, when we talk about the period, we're talking about the amount of radians that it would take to get this back one full rotation, or to get back into the same value that we started with. Okay, it's pretty straightforward for sine and cosine. The period is equal to 2 pi. Why is this true? Because it takes 2 pi radians to get back to where we were to begin with. So let's say, for example, let's say I talk about this angle and I talk about this angle theta. Then that means that there is some point over here on the unit circle, which is x and y. So if I talk about, for example, the sine of theta, notice that if I traveled from this point and I traveled all the way around to that point again, I would have traveled 2 pi radians. So the sine of theta is the same thing as the sine of theta plus 2 pi. So there is an equivalent statement, and all we're doing is basically just traveling around a circle. Same thing works for the cosine, right? The cosine of theta is the same thing as the cosine of theta plus 2 pi, because if I'm standing here and I walk, and I take another 2 pi radians of a revolution, I get back to the same spot where I was before. So sine and cosine have a period of 2 pi, meaning the amount of radians to complete one full cycle. All right, but what about tangent? Why is tangent only a period of pi? Well, take for a moment, let's consider the exact same picture for a second. So let me get rid of this, okay, all of this stuff here. And let's consider that same angle theta, okay? This is my angle theta. This is my point x and y. If I travel only half of the circle, and half of the circle in terms of radians would be pi, notice that I would end up at this point over here, and this point is a value of negative x comma negative y. Right, because I'm in quadrant number 3. By the way, this is quadrant 1, this is quadrant number 2, this is quadrant number 3, and this is quadrant number 4. So if we consider for a fact what the tangent is, right, the tangent is defined of my angle theta as the y value divided by the x value. That's what it would be here. Notice, what would it be in quadrant number 3? The tangent of theta would be negative y over negative x, but that's just the same exact thing as y over x. So therefore, it only takes me pi radians to get back this same value versus with sine and cosine. So therefore, the statement that we can write for tangent would be the tangent of theta is equal to the tangent of whatever angle you're starting with plus pi. So these are the statements that we want to take away from box 1, and hopefully the picture illustrates why the period for sine and cosine is 2 pi, but yet the period for tangent is only pi. Okay, let's do box 2. Let me show you examples of how this works in practicality. If I'm trying to find the exact value, remember everybody, we want exact value here, so no calculators, no decimals. I found the sine of 9 pi over 4. Here's how you would use a periodic property to use this. The sine of 9 pi over 4 is the same thing as the sine of 8 pi divided by 4 plus 1 pi divided by 4. Okay, this is an equivalent statement. Why is this true? Because 9 pi over 4 is the same thing as 8 pi over 4 plus 1 pi over 4. Now consider, what is 8 pi over 4? Well, that's just 2 pi, right? So look, I have 2 pi plus an angle theta, pi over 4. So it must be true that the sine of 9 pi over 4 is the same thing as the sine of regular pi over 4, because I'm in the same spot. And therefore, we all know 45 degrees, and the value is read 2 over 2. So that's how I would use a periodic property to find an exact value. Let's take for a moment the tangent of negative 5 pi over 4. All right? I know from before, since tangent is an odd function, that this is equal to the negative tangent of regular 5 pi over 4. It's an odd function, so I'm allowed to do that. That's equal to the negative tangent of 4 pi divided by 4 plus regular pi divided by 4. Now that is good for us because that is just a value of pi, and that's a period for tangent. So therefore, this is the same thing as the negative tangent of the other angle I have left over at pi over 4. And we should know that pi over 4 tangents is a value of 1. But since I have a negative out in front, I'm going to have negative 1. So therefore, the tangent of negative 5 pi over 4 radians is worth negative 1. Okay, here's a U-try. Use periodic properties to find the exact value of the cosine of negative 9 pi over 4. Don't forget your even and odd properties. Hopefully you got the right answer of radical 2 divided by 2. How did I get that? The cosine of negative 9 pi over 4, since cosine is an even function, it's the same thing as the regular cosine of 9 pi over 4. I broke that up into 8 pi over 4 plus 1 pi over 4. 8 pi over 4, of course, is worth 2 pi, which means I have traveled a full rotation. So the answer would just be the leftover angle at pi over 4, and we should all know that by now the cosine of pi over 4 has an exact value of rad 2 over 2.